So first of all, I make a processing setup like that. The lead file is input in your load graph. This lead file has some frame range like that, right? So this is your project setup is also frame range is matching your lead file. This means this lead file is first coming on your node graph. So that is why this range and this range and this range setup, right? But actually, we work the 1001 is our first frame, right? So here, this expression. Before I told you expression is like that. I show you expression. I make some multiply in here. Another multiply in here. So this knob and this knob. This is multiply 1, right? This is multiply 2. I click the control button and here, drag in here. This is expression. Or in here, you see, here, like that. And I check in here, edited expression like that. So what is here? What typing? Parent multiply 1 value. This means this node name is the value. The two tip, you see, this is the node name. So this is value, and this is another name, mask channel input like that. And this is the channels like that. This is node name. So this parent means this parent and this is the baby, right? Yeah, like this. Yeah, 11 recording. Yeah. This is if you changing this knob in here, this expression is also same changing because your parent is the same changing, and so this is a son, right? Or I don't know, son or girl, I don't know. Yeah, this is the baby. Yeah. So that means like this. These parents multiply 1, and this node name, this is node name. If I changing this name is to 3 like that, this is what? This is also saying changing 3 because your parent is different and changing, right? So here, so this is the hotkey like that. In here, you see equal. Is it right? Equal? Yeah. So you click this button and equal like that. You get the alphabet. But this is the advanced step. So I just only explain now. So actually, why I explain this? This is your parent is changing, so your baby is also changing, right? This is expression. But if I using the expression like this, only like this, no, multiply 2 like this. So value is number 1 is 2. Value is number 2 is 4 like this. In this case, we're using the expression. Or, before we make a tracker node in here, so you see this 7 and this value, something is problem. I think this is some bug, but if I just moment, save. And they compose it in. This is the expression, but something is the problem, right? Yeah. Actually, this not have a label like that. This means just get the your value curve. This means you wanna get the value. What value? This value means this value, because this value mean no name is value like that, right? So I show you this shuffle in here. So this is just in one, right? No name is in one. So I get the name value in one like this. What's happening? Yeah, shuffle below the RGBA. Something is typing like this. So this means this value's name is come to here. So because I make the value, I wanna get the value. What value? In one. This is non name. So like that. So this is so actually, this OpenLEC 70 color space name is here, right? Because the node is lava is not here. This is the default setup. Already, like this script in Leadify have like this script. So that is why like that. So we're using this is only explained for the like this lava we can use, but here this is some problem. So I think you can have some a little bit bug, and also expression have some little bug but the binary is not changing. Only the node level is the problem. No, this is now is okay, right? So actually we're using the expression like that because you make your compositing some value is the number one, but you need to what? Mentors is important. Focus in here. Yeah. Actually, like this, but I make another thing, color correct in here, but this is clone RTK. RTK is edited and here RTK. So clone means like that. This clone and this clone, what happening? The name is same, right? Because this and this node is same node. Understand? But this and this is different node. So only this node is different, but for example, this is me and this is Apple, but we have same information for us like that to share like this. This is the expression. So, but this is the only cloning. You understand? So if I what? Yeah, same value. So you see this node, and this node. It's only same value like that. So if I changing this node is also same, right? So this node is also, and here is also same. If I control left node is same, right node is same, because this is node is same for the cloning. So I'm using sometimes the cloning here like this. Oh, this is also same, right? But I'm using this node. But sometimes I want to change something in here from here later. So click the Alt Shift K like this. This is this connection you're cloning, right? Only cloning have this C label, but this is not now. This is the isolation. You understand? And then you control a little bit like this, or a little bit like this. You can control. So this is the now individual node, right? This is, yeah, decloning is here, declone, Alt Shift K like that. So expression and this is different. I make another multiply in here, like that. And also, you see multiply 1 and multiply 3 like that. Expression, this button and here is also same. No. Control in here with your control button. And this is same. But this is something is different. You see this arrow. That means this data go to the here, right? This data go to the here. From multiply 1 to 3, right? So that means you only control this value here, not here. Yeah, because if you control in here, what happening? Always this means you see this color is changing, right? No color is changing. That means your animation is activating. So that means you click here, your key frame is already your keyframe. You understand? So if you change like, oh, why I didn't move like this. This is only changed here. So sometimes we don't need this keyframe, so we delete the key here also. You understand? If you click the no animation like that, the full expression is broken. Only current value is still in here. Understand? So I mean, so now like this. So you understand this expression and this cloning is different. So principle, you understand this, the principle working the progress.
Sir, could you try the same trick you did earlier where you could move all the expressions of the clones?
What's the name?
The one you did earlier. You change one node and these two also change the expression.
The expression?
Yeah, the numbers.
He wants to see if those two will
Will-
follow the multiply.
Sorry, can you explain again?
He just wants to see if if multiply 2 and multiply 3 will follow if you change multiply 1.
Multiply 1 and multiply 3.
And
2 also.
and then if you change multiply.
All of
Yeah,
them
number
are-
1 is like that. Because number 1 multiply is this expression is the only copy your this value, and this expression is multiply 2 here. If I set up like this, so in this case also, if I change this value is 2, this value is 1, result 1. 4, 4. Yeah, this value is what? 2. Yes, 2 like this. Yeah, because this is the expression. Your parent value is changing, so this is expression like that. Actually, expression is the only node is expression, right? That means if you make a tracker node in here and make some tracking, for example, actually I get the tracking data like this, and then let's go like this, and then make it like this, right? This is the link expression, right? That means you're tracking transform data. This is your linear data, and also this is this same data in here. You can check here it's the expression like that, what happening? Yes, like that. So actually, in this means this is also, you see here, like this. This is expression. So many expressions you can have. So that means simple. You understand. Just I wish. You can now this is advanced proof. So after that I will explain this. You can read that, but this means the track one. This track one translate x. This means this is translate x, and this is the translate y. Y value. So you get the translate x value. Go to your x value. Understand? So this means like that. Invert. So actually, this value comes to here, and this is expression, right? So another node is not. This node is not expression, right? I mean, expression is you control your node. Only your individual. If you want this node expression, or go to the here expression, control. But cloning is the full node is already changing. Full node. Here is also, you see, this highlight, I will change like this. This is also same, and this is also, and this is also mix is also same. So this is difference, expression and forming. So just thinking, which node is the heavy? Yes. Expression? Expression is heavy than forming.
Because expression is mathematical. It's
No, I don't think so. I think cloning is the more heavy because we need to whole node is the copy and cloning, right? So if I here the node, this is also same. This is also node. This is also node. This is also node. If I changing like this is also node like this. Still like this. So cloning is the whole node is the changing. So that is why the more heavy than expression. Expression only one node. Change the something another thing. Not one node. Actually we using the expression so many and then we control another thing like that. That don't depend on something we make another thing. If I make another thing, I make some expression another thing like that. But expression, Jason told me expression have some what is that here? What like what?
Mathematical computation.
Medical.
Computation.
Medical?
Math.
That's complication. But that is, I think that is more faster. That is more faster. That calculation is the more faster because this is programming. Yeah, this is also programming, and this is need to be changing the another Python another thing, so you can change the another thing. So that's a little faster, but cloning is a little heavy. That means if you make so many cloning in this on your node graph, your node is so really heavy. Also, tracking node is also tracking that node is dimensional data a little bit heavy. So if you make a tracking like that, before we work tracking so many make a tracking nodes because this part different, right? Actually, you're using the only one tracking node and then click and then export. I mean like this. So sometimes I also make a tracking node like that. But if you make another tracking like that, and then if you only this and this part you using for the leisure. So this is enabling here, and then you only this data go to the here, and then you link in here, or in this case, not link, only bake mode, like this. Because this, I wanna change another tracking value in here and bake it. This value and this value is different. Understand? So and also, in this case, I'm using the translate and rotate like that, or scale also. If you I click or 3 like this, and then in this case I'm using there's only 3 data in here, and this is the another value. So because baked mode, you make a bread like that. The oven is open, and then you bake it, and then comes get your bread. This is baked. So that means your keyframe is still baked. You got some keyframe, right? So, I mean, you understand, you see, you like that, you understand the principle. This node, understand? So, actually, sometimes you're using like this, like that. Well, anyway, another thing like this, so you can control. This is also another way for the tracking, because tracking node is so really heavy. So if you make a tracking, so many tracking in here like this, yes. And also, you see, everyone see here. If I click the control button and here below your node, this node is you can control like this, yeah, like this. Or if you only here, this control like this. So this is the further organizing keep your control. So this is the further expression. And also, backdrop is also control, and this button is you can change it, your movement. So what you understand what is difference between expression and cloning? And now you see this is the brushing button. That means only not brush it. This is have an alpha. So you can control your alpha data like this. That means if I using this data in here, with your brush in here like that, something is problem, right? Like this. If I remove this data alpha, this image have a alpha, right? already have alpha. But here I make alpha is known here with your shuffle node, and then not paint like that. And I'm using this data with copy in Primo like this, like this. Because this roto paint have alpha with your brush here. Understand? But you see, this is the eraser in here. This means the erase your alpha. Erase like this. You understand? This is different. So, because I mean like that. If I make a roto paint in here, why anyone is curious like this brush? Why anyone is do not ask me this like that another things? So I just only before I told you like bit of for the lecture, I told you be curious something and another things. Only accept my lecture. I mean, you do not only accept my lecture, you do more curious or something like that. So this brush is the have some alpha in here. So eraser is inverse. So opposite to me, so you can use with the alpha like that. So sometimes if you're using that brushes for the alpha maker, the most like this because it's everywhere have an opposite slow and the value is the low and then you'll see. And anyway, it ain't something like that. So you can use it like this. But so this is very helpful for the local painting, both maker alpha. Like this brush, this will have some four brush alpha in here. But actually, sometimes the brush is like that, some holes appear. So you can check your hole like that. That's very important. So before I told you reveal, right? Reveal. Yeah. This reveal. This reveal is depend on your this busy. You see, this is the color, and this is busy, right? Something is different, right? This color mean. So here, this is also color, right? So I change the color in here. Change color like that. You see? So like this. Like this. Degree. Anyway, like that, you can make some drawing in here. So anyway, you see, before I make a where is it? Brushy color like that, this color is changing like this, right? So that means you make a like this, and then you can change in the color in here also. That means because this knob and this knob is same, right? So if you make something is like that, and then you change some color in here like this means like that. So yes, and also Lotto and Lotto paint is something different. Why difference? This is the, you see, Lotto have output is alpha, right? and multiplies the none. But actually, load to paint is output is RGBA. This is different. So if you see output alpha, so this is mean like that. R, this R, G, G, B, B. Only A is the alpha is output here. But load to paint in here. I will load to paint in here. Same thing. I shape same, right? Actually not same. Yeah. Anyway, I make the same shape in like that. This later, duplication and cutting here, and pasting here. What happening? Root 1 is the RGB no data, but only alpha data because root 1, why? Output is alpha like that. But root paint, output is RGBA, right? That means the root paint RGBA data. Yeah. And also, this is just before I told you here, you can change something in your like that. You see? And also, auto paint is here. If I make a bezier in Lotto pen, this life is alright, but both is have a life with one single life, and the next frame is the both is on, right? So understand this how it's working like that. So this is our lead file. This is org, right? So we always make a final data in here. Top to button, right? This is our workflow, and also make a merge in here. This is our B, this is our A input in here, right? And also another merge in here. This is also B, like this. We can using like this, and sometimes this is our this is our main B pipeline, but sometimes here another work with merge, and also here B, A data like this, and input here. This is also, you can make a B pipeline like that, and this is your sub B pipeline like that. So many B pipeline coming here, right? So about your main tree, this is the organization for the work. So you're thinking, and this is only depend on your work progress. So this is up to you, and maybe some layer in here, so you only the one merging, you can using only one merging like that. Why I using the B pipeline? We always the disable, right? And then check disable, and then check your original or final data like that. And So B pipeline like this is very important, and also top two button, but so many node we sometimes we make so many node, right? So at the time we left and right you can work. Understand? So you're organizing your script. This is our rule.
Sa pag gumagawa siya ng
So this is the B pipeline, right? And this is led by ORG. And first step, our work like that, remove something or replace or add something, add your FX or another thing like that, or stabilizing your putties or lead time. Sometimes they're fast and slowly like that, or slowly or slow and fast like this. You can make some lead time, and another thing, so many work here, right? Actually, remove and replace and add your effects and other things. This is the like the ORG plus your another thing, right? Remove is just the plus because that means your footage in here, and this is a person like this. So you remove this like that. You remove like this. This work maybe, for example, this description is remove your like this eyebrows. This is work, right? But I mean, you patch in this case, yeah. You need to this matte painting, right? And then merge over in here, right? So we need to this matte painting later, right? Always something is the ORG and something is the plus. This is also plus. This is also plus, right? Actually, this data and this is something is different. This work is like this way, but this work is only the stabilize the camera shaking like that. But director give to some stabilizer for the putty. So there's our description. Only we make some tracker node in there, and then we make her stabilizing. There's our work. You understand? Because sometimes like that, I make some shooting like this, but the ground is not yet stabilized. So something is wrong like this, have some jitter. So the director do not need something that jitter. So remove that jitter. So you make our tracking data, and then this is the still and something is the jitter, but we have a tracking data, right? So you can using that data and then you can make some stabilizing. Understand? Because stabilizing mean like that some position is following only still in there, right? So we can make it like that with our tracking data or another things. So and then before I told you I using the curve in here like this. I control like this. You see here is also something is a problem like this. I think this data is not good. So you can using this data also make some filter like this filter, and then this filter number of time of the filter. The number 1 is like that, or number 10 is like that. Something is changing, not changing here. Filter like this. So something is filtering, but this means that your first frame value is also changing, right? So if you're using the filter, if you make the high value in there, fit in there, that is your first frame value and end frame value is changing. So that is very dangerous. So you can contour a little bit, or you can make the more smooth, and then you understand here like that. Actually this is also, you see this is a little bit straight, but actually this is also have some curve in here. So because have some jitter, because we already make some jitter. Still on that position is very difficult further. So for tracking, get the tracking data. That means before I told you, always the actually 100% data is not exact here. Always just have some little bit jitter. So you can control jitter with your filter like that. Like this, you see? And you see here, first frame is the value is changing, right? That means actually the first frame is our reference frame. So reference frame means now is nothing is happening because this is reference frame. So that means your translator also is 0, 0, rotator 0, like that. And then now this reference frame is based on your frame. So now I will start on anything on your data, with your data, understand? Maybe in here, reference frame, another frame is go to here, another frame go to the here, another frame go to the here. Understand? This is you get if you have like this tracking data.
It's the basic.
Yeah. So reference frame, that is a
Basic.
basic frame, and then I told you this reference frame very important for the work. So understand what is reference frame and other things.
Can you only select few frames to filter? Can you select only specific frame to
Yes, if I make some filter in here, this is some problem here, but make a poor sometimes difference, but actually I make using some filter in there. Actually, the whole keyframe with Control A and then pick your full frame, and then I make I using some filter because I wanna when I using why I using filter. That is why I wanna more smooth your curve. Filter means the filtering the most smooth. So that is why I choose the whole point, full keyframe. Understand? Because only I filter in here, maybe only I filter in here, like that. I think. I'll show you just a moment. Some plate like that. So I make a tracking here like that. Before tracking data in here, so I make some tracking in here. No frame range on input clip like that. Why this pop-up is here? Because checkerboard don't have a range. I mean, no frame range. So you check your pop-up here like that. So something's better. What? No frame range on input clip like that. So input clip, this clip, right? Actually, this is the input for the tracker node. So, but in this case, this checkerboard still image. So that means this is don't have a frame range. So, but I make a frame range like that, frame range like this, like this. Now this have some frame range. So always we click this button, volume up, and also this television TV also volume up, right? With our input and output. So this is just to say we input data is 1 to 100 frame range, and then if I make a tracking in here, it's okay, right? But actually now I try again because this don't have a range. But actually checkerboard have a frame range. You see lifetime range in here. If you click use lifetime and then here want to like this, and then I'm using this also. This is also like that. I think some bug was like this in here. This means like that. Sorry. This is the only sorry. This is a frame range, and this is a difference. This is a lifetime. Before we using the lifetime on Lotto Paint like that or Lotto, this is only lifetime. So if I use it, if I go to the back, it's gone, and also back is gone like that. This is the lifetime. So if I only using the 10 to 20, only 10 to 20, right? This is a lifetime. So that's why we're using the frame range in here. Anyway, I make a tracking data in here. So this is our So I want to using this data. The curve you can see here translate. You see this translate means this transform translate this value and this value is same. This value, you see this here is the negative 1.3 and this y is the negative 1.3 like that. So and you know what it is? Trans x, trans y, and x, and offset y x, offset y, and e also, and error also like this, and center like this, error like this. This means like that. This is all data for the tracking, but you understand? Translate xy is the from transform tab translate. Understand? And tracker in here and this track one. This track one is mean track one. And you see track x in here, track x in here. So anything is not here, you click the F button like this, to fit in your graph. So this value is in here. So this is 1000 like that. And also this value is here. So if I shift like this, I click the full button like that, and I want to a little bit shift like that, a little bit shift, right? So you can make your sometimes I following the tracking. I make some tracking data, but sometimes the cross frame is okay because that is our reference frame and baseline frame. But end frame is a little bit right. But I wanna following that position in here, but tracking data a little bit. So, yeah, so need to offset. At that time we can using the here, the first frame and end frame like that and like this, a little bit shift like this. You understand?
Sir, can you select
What?
the offset? Is the offset that specific frame? For example,
Actually, offset. I will explain another case because in this case, I will show you some jitter in here. So actually, this is our filter. So filter like that. Number one like this. You see number one, 10. This frame is our base frame. So this frame is the here. And also, you know, this yellow line is our indicate bar, right? So in here, and also this is the 100 like that. So this is the one frame, and one frame value is 0 because our reference frame 1 and translate 0 value, right? So I have some jitter like that, but I want to more smooth this jitter, so I can using the filter in here, so maybe like this. But our first frame something is changing, right? So you see the something is it's filtering. You understand? Yeah, this is filter. Have a more smooth your graph. So and then I will show you just a moment. This is original and this is building the filter. I control like that. X filter changing like 5 like this, the most smooth, right? And Y is the filter, 5 is the most smooth. And I check this.
Sinabi mo yun.
What is the iPhone is the more? I think iPhone is the only one. One is the turn on. So this is the original and this is the filter. You can check. Oh no. We using the match mode data. I make the more filter in here. Oh, just a moment. Filter 5. Filter Y also filter 5. Yes, and then check this. This is have some more smooth, right? This means the filter maker your data is more smooth. So if you're using the filter, you check your first frame value and your end frame value, because your first frame is there still in not changing, right? Yeah, like this. So this is the filter, and I make some. Why I frame filter in here? Anyway, why I explain this is I think I mean this rule is the before I told you, right? But this is important so you understand, and I wanna you need to why I make a note like that. So this is a rule for compositing. So B pipeline is important, and so before we always ORG and plus another things, right? But this stabilize and lead time is the default word. So because only we have a matchable data, we need to stabilize it. So that means our grain is not changing. We need to not grain changing only because they're only stabilizing. So actually, always we need to make a ORG to denoise. So this is your first step for work, because if you make some matte painting here or replace also add also, this is maybe sometimes this is the still image, and this is just a still or another movie, another video like that. This is another FX element or more like that. So you match your grain. So we always the denoise workflow. Denoise workflow. This is very important. So first of all, I make a denoise plate, and then isolation your ORG grain, and then I work your B pipeline modes in here. And then finally, your grain is over here. Understand? But if I told you we're using there some dust grains or another grains, so many grain here. We have so many grain nodes, but actually dust grain is very useful for work. So, but this need to some ORG data or D grain data and mask. This means you change only this grain, understand? Because another area is we using the original data, but here is we only change the lead grain. So this is the original grain plus lead grain. So you can using the mask data in here because we have this mask data because we patch your matte painting on your original data. So mask you can use in here. So dust grain is over. But I make in dust grain in here shuffle, right? Why I make a shuffle node? Because I wanna make your alpha data 0. So actually, this is heavy alpha, right? So dust grain. This is a plate like this, sometimes like this. No, like comp. Actually, this comp is your final work. Now it's for example. So this diagram plate is the diagram and actually like this. This is your original data and idea. Anyway, this is our confiner and this is our original data. So this is our noise grain plate. So grain plate in input here, plate is input here, original, and comp is our final data. But this comp is based on your grain plate, right? Your B is because this is our noise workflow, right? So and then this mask also only here this is the alpha, right? So this mask is also in here, and not here. This alpha data. So I can use it like this, but in this case, this is have alpha. So here also have alpha, right? So that's why I make some grain in here. Make for example in here. And click this activity in here. Like that. And analyzing this, put it in here. Now I make some electricity grain in here. Right, this is not. Grain is not like that. Oh, this grain is not good. Wow.
There's no grain.
I think this place have no grain. Why? So little. Oh, so. I think this is the 3D data. 3D data. So actually, if we using another thing.
This 3D, how do you apply noise?
What?
On a 3D comp,
3D comp?
how do you apply noise? That
Actually, 3D data have some grain, but this data, in this case, this data have no grain. Actually, 3D have some grain, and also maybe full 3D can't have a grain, but actually we sometimes the original plate and over 3D, right? That, but this 3D have no grain, right? Or I mean. We match our original plate. 3D grain also match your original grade. Understand? Because this original plate is always our based on plate. Based on drawing paper. Oh my god. Anyway.
Yeah.
So now I check the grain in here like that. So this is adapted grain. This means your grain adapted your confiner, luminous or color like that. So now I check this alpha. This alpha has full alpha. So that is why I'm using the shuffle in here. no alpha. So because if I merge in here, this data, you final like that, but something is the problem, your RGB. So that's why using the alpha is removed. You understand? Actually, if I stay here, actually in this case, I'll remove the alpha here, right? Because I only the over your grain in here, right? But here, this is auto alpha is click, right? That means this plate have alpha, but this click is no alpha in here. At that time, only over. This is also problem because I think this is complete have alpha in here. Plate no alpha, but denoise degrade plate have alpha like this. So this data have an alpha like that. So that's why using the couple in here or this data. No alpha and then merging like that. Understand? Everyone understand? And also, you see here, allotted grain QC, and leak grain comp like that. That means like this. This is the grain workflow, right? In here? Because this dust grain, we only using this grain RGB. But if your alpha is the full like that, this RGB actually like this. So that is why the overall like this, you do not using like this. This is your final. So you only the overall your RGB. Yes. Also, actually, I'm using this data another way like this. This is D-grain plate, and this is plate, and this is our mask, and this is comp. And here, I will see focus here. I organizing the node like that and changing this leak grain pump. And this lizard and this lizard is same. Understand? This lizard, this means the leak grain comp mean is the already your grain adapted and then over your comp. Yeah, in this comp data. This comp data is our denoise workflow finder, right? This data. So this leak grain comp is this adapted grain is over your comp data. So this is simple, right? But why are you using like that? This is my suggestion. Because this means the only input you input your plate and degrade plate and mask and comp, and then this is your binder. But this is just your final. This is same. But why I suggestion this way? Because this is very difficult for your control grain. But this is your control your grains like maybe if I'm using the more grain in here, the more color grading like this. I wanted the more red in here, so here like this, yeah, like this, or only here I wanted to make the grain the red. Like that, so I wanted the more like this. Sometimes the grain is not correct. The dust grain, the result, the dust grain is the calculation your grain, right? But the result is not good sometimes, so you can control that, right? So I wanna make this grain is also for your layer. So this is your B pipeline, right? Understand? Everyone understand? Yes. So actually, this is also B pipeline. You can make it. This is B pipeline. But for this, in this case, I wanna explain like that. Yeah. So this is your grain layer. So denoise workflow is very important for work. Denoise workflow. So you can finer here in your dust grain and sharper in here. So over. So this is your final data. Everyone understand? Okay. And the others. The loop for composting, we always do. It's right, organizing. Why? Right? Organizing. Organizing your data. This is very important. And our script name. This is actually our shot. This is the shot. We have some shot name like that. Like this. This is shot name. This is Nuke Studio. Nuke Studio. So I make here. This is have some another a little bit similar for Nuke, but this is some difference for Nuke. This is the Nuke and combine some edit tool. So you can cutting like that edit and then make some comp. So in this case, I mean, we have some this code name like that, right? So actually this is sham name. So sham name underscore your comp underscore your version like that. But sometimes the client have a space is only 2, or sometimes client have a 3. But our basic is 3 spacing, and then you make some version. Sometimes you need some feedback or another. You can modify another thing, so you can version up like that. So actually, sham name and comp like this, and also this is very important for the naming. And your final data always follow your script naming. But sometimes we make a short name mask or version 001 like that. Your spacing, this spacing wants to if like this or if star. Or we TIFF is very light format, so you make a mask with your TIFF file. That means like that. This is just a TIFF file, like this. This means this is our background. I make this background and this you can using the mask like that because I wanna make this data. This data have red data, right? Only red. So that means the I wanna using this red data go to the your alpha. Only changing your alpha is alpha, but I wanna your red data go to the alpha. So that means this is have alpha like that, but actually like alpha is like this. So in this case, I'm using your alpha in here, so make some coloring like this. Understand? So in this case, we make some mask. So like this mask. So we using the TIFF file like that. And our final data, we always render two type. Also, Sean name or font or this your version and MOV like that. This is the for confirm because MOV is so really light and but another sequence we always make Avi before told you we always just sequence work. So sequence is the have a shell name comp version. This is your directory and your file name. And also using the or DPF. This is depend on your LID file. So actually, this naming is also important for work. Everyone understand? Okay.